Welcome to the Explainer. Today, we're diving into a huge tension at the heart of AI. Models are getting smarter and smarter, but they're also getting unbelievably expensive to actually run. So what happens when genius-level AI has a price tag that almost no one can afford? Okay, let's get into it. And this really is the central question, isn't it? We're seeing AI agents do these incredible things, but the cost to operate them is just exploding. And that creates a massive barrier, threatening to make the most powerful AI totally inaccessible for everyday, practical use. So let's start with the core of the issue, the high cost of genius. For years, the unofficial motto in the AI world has pretty much been, build the most powerful thing you can, and we'll worry about how much it costs later. But that whole approach has pushed us to a major turning point. Now, that philosophy, it's given us some amazingly powerful models, no doubt. But when you start asking those models to do complex, multi-step jobs, the costs just become unsustainable. So researchers are now saying, look, efficiency can't be an afterthought anymore. It has to be part of the design from the very beginning. And to even measure that, they needed a whole new metric. And that metric is called cost of pass. The best way to think about it is it's not just how much you pay for one try with the AI, it's how much you end up paying to get a single correct answer, right? Because a cheap model that's wrong half the time could actually end up costing you more than a pricier one that gets it right on the first shot. A low cost to pass, that's the real goal for efficiency. So with this new cost to pass metric in their toolbox, researchers started digging into these complex AI agents. They really wanted to figure out what's actually making an agent good at its job and what's just making it expensive. Okay, so take a look at this graph. It lays the problem out perfectly. The up and down axis is accuracy. Higher is better. The side-to-side axis is cost. The further to the right you go, the more expensive it is. See that pattern? To get those really top-tier accuracy scores, the cost just shoots through the roof. Look at that model in the top right, Claude 3.7 Sonnet. It's the smartest of the bunch, but it is by far the most expensive to run. And this quote from the research paper sums it up. The big push for effectiveness, raw performance, has come at the expense of efficiency, or what it costs to get there. It's a trade-off everyone's just kind of accepted for years. But just how bad has that trade-off gotten? Well, check this out. This is the cost of pass for that most accurate model, Claude 3.7 Sonnet. To get one correct answer, you can expect to spend $3.54. Now, compare that to GPT 4.1, which has a cost of pass of just 98 cents. That's a huge difference, and it points to a really big problem. The researchers actually have a name for this: overthinking. It's when an AI agent just churns and churns, using a massive amount of computer power on a task, sometimes for just a tiny, tiny improvement in its answer. Or even worse, no improvement at all. This overthinking is just a major source of waste. And this brings us to what might be the most surprising discovery in the whole study. When the researchers went looking for the biggest source of all this inefficiency, they didn't find it where you'd expect. They found it in the AI's memory. And the solution was completely the opposite of what you'd think. So they tested two main ways for the AI to remember things. On the left, a complex system where the AI writes a little summary of its past actions to save on memory. On the right, a super simple system that just keeps a raw list of everything it saw and did. Now, you'd assume the summary would be way more efficient, right? But it was the exact opposite. The complex memory was actually more expensive and less accurate. In fact, that simple memory system had the absolute best cost of pass of any single setup they tested, just 74 cents. I mean, that's way lower than the fancy, complex memory, and even better than the original model they started with. It was a totally stunning result. And this led to maybe the most important takeaway in the whole paper. Simple memory is enough. All those complicated, expensive tricks designed to help the AI remember better by summarizing things, they were actually making everything worse. Just letting the AI see a raw log of what it did and what happened, well, that was not only cheaper, it worked better. Okay, so putting all these pieces together, the researchers decided to build a brand new agent from scratch. This time designed from the ground up for maximum efficiency without giving up too much performance. So here it is, the recipe for their efficient agent. First, for the brain, they picked the more cost-effective GPT-4 one. Then, to stop that overthinking, they put a hard limit on its planning steps. They also found that using multiple search sources helped, but running the model multiple times to pick the best answer just wasn't worth the extra cost. And of course, for the final key ingredient, they used that surprisingly powerful simple memory system. And here are the final specs. Every single line on this table is a decision that's backed by their data, a choice made specifically to get that cost of pass number as low as possible. See there? Max step is capped at 8 to stop the overthinking, and memory is set to simple. This isn't just a boring list of settings, it's a blueprint for building cheaper, smarter AI. Right, so the moment of truth. How did this new, lean, mean, efficient agent actually stack up against OWL, a top-tier agent known for its really high performance? The results were pretty incredible. The new efficient agent kept 96.7% of the performance of the much more complex OAGL agent. So basically, an almost unnoticeable drop in how well it worked. But what about the cost? And here is where all that work really paid off. The super high-performing OL agent had a cost to pass of 75 cents. But the new efficient agent, built with all those cost-saving tricks, brought that cost all the way down to just 55 cents. That is a serious improvement. What does that all add up to? This right here, a 28.4% improvement in cost efficiency. By being smarter about how it was built, especially its memory, the efficient agent got dramatically cheaper to run while giving up almost nothing in performance. And all this leaves us with a pretty big question to think about. Maybe the race to build the future of AI isn't really about raw power anymore. Maybe the real challenge, the real genius, will be in building agents that are fundamentally smarter about how they use that power, making sure that brilliant AI is something that can actually be used by everyone. Thanks for watching The Explainer.